Good afternoon, everyone who is watching this presentation. My name is Sasya, and I am the team lead for the team Asterix. So, for today's hackathon, we have chosen a very innovative challenge regarding the industrial aspect. In today's world, we are using the machines everywhere, and the risk of the machines failing is very high. So, we have created an ML model using logistic regression and generative AI, which uses sensors to gather the data from the machines, and using the Gemini's API, we connected this the output generated from the ML machine to our Python code and created a website which shows the real-time stimulation of the data. So you may ask, what are we getting from this ML model? From this ML model, we can predict three cases, that is optimal case, worst case, or a warning case. Uh, our ML model uses a formula regarding the percentage. It will calculate the percentage using three main factors, that is temperature of the machine, vibrations of the machine, and power used to work on that machine. And using these three aspects, it will calculate the probability of it failing. So if the probability is less than 40%, it will show you the optimal case. If it is between the 40 to 65%, it will show you a warning case. If it is higher than 65%, then it is in the critical stage. And it is our model, and the code you are currently viewing is our ML code. And let me just use my Gemini API to connect this with our Python code, which we have used to create our website. And this is an API key which we have used to connect these both the files, and we have used Streamlit to host our website. As you can see, I guess it didn't load yet. Yeah, so this is our dashboard, and you can say our website. uh, this is our front dashboard, where you can see the current sensor readings generated from the machine. You can also see on the left side simulation control. So when you start this live feed, the ML model will start to gather the data from the machine, and you can see that live proof in this historical data. As you can see, we are getting a timestamp, and it is using temperature, vibrations, and power drawn to calculate the failure probability. As you can see, it is continuously generating data, and it uses data to generate this graph. This is a live graph which is being generated according to the data by our ML model. And you can also see here the system info on which this ML model is being deployed. The codes for this both programs are provided. And this is our and if you don't want the ML model, and if you want to inject the data by yourself, we have a manual data injection too. If you stop this live, and you can enter the values. You can't enter the values less than 70 degrees in temperature, or else you will get an error message like this: the value must be greater than or equal to 70. So when you enter 70, and the same goes for vibration and drawn power drawn. uh, you can just manually enter the data. As you can see, when I started entering the data, our model has went into a manual mode. As I already told you, it is testing against a warning 40% and critical 65%. And you can exit the manual mode if you want to again enter the date. If you want your ML model to directly generate the data, you can just start again the live feed. So this is basically your presentation. We have used in Gemini API keys and logistic regression ML model to generate this ML model. And that's all. Thank you.